Yes, my dear students, this is one of the appeared problem in VTU examination. What this problem says, my dear students. So you can look at the picture here, appeared question. It is a picture of the question paper. Then what we have, the same we have typed here. A full journal bearing of 50 diameter, 75 long, supports a load of 1000 Newton. The speed of the shaft is 600 RPM. The surface temperature of the bearing is limited to 60 degrees Celsius. Room temperature is 30 degrees Celsius. Determine the viscosity of the oil. If the bearing is well ventilated and no artificial cooling is to be used. So, and the ratio of journal diameter to the diameter clearance is 1000. So, if you look at the problem, my dear students, we need to design a journal bearing. Whose diameter is given and length is given, and also load on the bearing is given. Load on the bearing is, the speed of the shaft is limited to 600 RPM. The surface temperature is 60 degrees Celsius, 30 degrees Celsius. So what we are supposed to calculate now, we need to determine the viscosity of the oil. If bearing is well ventilated and no artificial cooling is to be required. The ratio of look at here, journal diameter to the diameter clearance. So my dear students, in simple way I am telling you, we need to design a journal bearing and we need to calculate the viscosity. How to calculate, my dear students? I'll tell you. So viscosity we need to calculate such a way we are supposed to use oil. Viscosity calculation is nothing but identifying the proper oil. How you are going to do it? My dear students? There is one condition he has mentioned. If the bearing is well ventilated and no artificial cooling is to be used, so which means whatever the heat is generated, that is going to be dissipated from the bearing. So during rotation of the any machines, so whatever the heat is generated, that dissipates automatically. No extra cooling is required. So that condition has to be achieved. For that purpose, we are supposed to use proper lubrication oil. That lubrication oil viscosity we need to identify. And one more thing, you can look at here, journal diameter to the clearance is he has given. D by C he has given, not C by D. D by C has given as 1000 RPM. Let's list out the given data. My dear students, he has given diameter 50 in terms of meter, zero point 0 meter. In terms of, so length is given, length is 75 that is 0.05 meter. Load W is 1000 Newton. Speed what is given? 1000 RPM is given. And temperature of the bearings, TB is how much? 60 degrees Celsius. Room temperature is 30 degrees Celsius. And D by C is 1000. So D by C is 1000. So just D by C is 1000. We want C by D, that is psi. So that is 1 by 1000, that is 0.001. These all are the given data. So now we move with how to solve the problem. So we need to know one thing here, my dear students. That is, what is that? This formula, 24.72A formula. That is from the Lingay data handbook. Heat generated equal to coefficient of friction, pressure, and length of the bearing, diameter, and velocity. These all things to be known. So now we need to calculate the heat generated. So after calculating heat generated, then we need to equate to the heat dissipated. So no artificial cooling means whatever the heat generated, that is equal to the heat dissipated. So heat generated we need to calculate, heat dissipated we need to calculate. Then one equation, there will be viscosity. Then after equating, viscosity will be only unknown that we can calculate. Let's calculate these all parameters. Yes, my dear. Heat generated equal to mu PLDV. So we need to calculate mu, we need to calculate pressure, we need to calculate velocity, and L and D are known. So remaining three things we need to calculate. First, calculate the pressure. Of course, my dear students, pressure calculation is simple. Load by area. Load is available. Area is L into D. So load you substitute 1000 Newton. Length and diameter you are going to substitute. After doing this, we are going to get the 0.267 into 10 raised to 6 PA Pascal. So pressure calculation, load by area, substitute the data and get the pressure. Then we need to calculate the coefficient of friction. Coefficient of friction can be calculated by Petrov's equation. Raimondi-Boyd curve as well as Mackey's equation. So what I prefer? I prefer the Mackey's equation. So Mackey's equation is available in the formula number 24.22. So what is Mackey's equation? This is the Mackey's equation. For this, my dear students, this Ka value and mu value, Ka value and mu value, that is fixed. This Ka is 1.95 into 10 raised to 11 for full journal, and also delta mu equal to 0.0002 for the full journal. So these two are constant values for the Mackey's equation full journals. Then remaining thing we need to substitute. Let's mu just write it as Ka value. You just substitute viscosity keep like this, and n dash is speed in rps. Rpm is 600 and divided by 60, that gives the rps, and pressure is 0.267 into 10 raised to 6, which we calculated. Then psi is 0.001, so we substituted. So into 10 raised to minus 1, we have, yes, what we have is, so we substituted K value, mu as it is, viscosity as it is, RPS as it is, and P as it is. Psi A value we have written, and 10 raised to minus 10, we have multiplied 10 raised to minus 10 and plus 0.002. So we write 0.002 as it is. Remaining these all term we simplify, and we get answer in terms of viscosity. Answer in terms of viscosity. Please look at this viscosity. We don't know the viscosity. So what we do? We call this as equation number 1. So heat generated, that is sorry, mu value, whatever it is, write that one, equation number 1. Then we need to do p we calculated, mu we calculated, then velocity calculation is remaining now. Now what we do? We calculate the viscosity, pressure, mu, then velocity calculation, pi dn by 60. So diameter is known, and speed is known. Just substitute velocity, we get 1.57 meter per second. Then heat generated formula, that is 24.72a. So substitute mu value, what we calculated, that is 0.07312 0.73125 mu plus 0.002. Pressure value substitute, L value substitute, D value substitute, and V value substitute. Again, my dear students, what happens after simplifying this one? So we get some answer in terms of the viscosity plus something. So call this equation as 2. Call this as equation 2. Okay. So now we need to, so now we calculated the heat generated. Now we know that one, heat generated equal to heat dissipation for no artificial cooling required. So for no artificial cooling required, heat generated equal to heat dissipation, that we are going to do. We are going to calculate the heat dissipated. Calculate the heat dissipated. Now we calculate the heat dissipation. So formula number 24.77. This is the formula, and C value is fixed for full journal, and A value is 25 times of DL, that is fixed for the full journal. So D value, just you take the C value directly, and 25 as it is, diameter value 0.005, length value 0.075. After this, we get the area as 0.0, A value as 0.094 meter square. Then uh, this absolute temperature is 30 degrees Celsius, which is given, or else if it is not given, you can assume whatever it is, 25 degrees Celsius or 30 degrees Celsius. Now it is given as 30 degree, no need to assume. So if not given, you need to assume. So bearing temperature is 60 degrees given, and absolute temperature 30 degrees given. 60 minutes difference between these two, 60 minutes 30 degree, so 30 degree. So now we got the C value, A value, and this difference value. Now what we are supposed to do? Heat dissipation calculation. Just substitute the C value, then A value, and TB minus TA value. Now we got the heat dissipation as 32.664.84. Now what we done? We can take this as equation number 3. So equation number 2 is heat generated. Equation number 3 is heat dissipation. We know that no artificial cooling is required, which means heat dissipated equal to heat generated. Yes, cooling is required, no artificial cooling required, which means heat generated equal to heat dissipated. From equation number 2, heat generated is this much. From equation number 3, heat dissipated is this much. So from this equation, only unknown is going to be viscosity. Just substitute and calculate the viscosity. After calculating, we get the viscosity 24.82 into 10 raised to 3 PAS. So according to the question, we calculated the viscosity when no artificial cooling is required. So viscosity is calculated. This is how the problem is going to be completed, my dear students. If any question, you can contact us in WhatsApp.